To show that the given here is a linear transformation, there are two conditions that should be met. We have here transformation from R2 to R2, given with this transformation of the R2 vector is equivalent to this here. Now, the two conditions that should be met is number one, if you're going to take the transformation of the sum of two given vectors, okay, let's say x and y, we can just simply rewrite them, or this is actually equivalent to taking the sum of their transformations. That's the first condition. Okay. As for the second condition, if we are going to take the transformation of a multiple of a vector with c scalar here, this is just equal to the same scalar c times the transformation of the same vector. So if these two conditions are met, then we can say that the given is a linear transformation. If one of which or both will not hold, then definitely this is not a linear transformation. Let's start with the first here. Of course, we are going to define our two vectors here. We have vector x and vector y. Let our vector x be equal to, because we have here x sub 1 and x sub 2, let's also use x sub 1 and x sub 2 here. And of course, if we have a vector y, this would be y sub 1 and y sub 2. So let's try to verify the first condition. The transformation of the sum of the two vectors must be equal to the sum of their transformation. Okay, the sum. So we are going to use here the transformation of the vectors first. X sub 1, x sub 2 plus y sub 1 plus y sub, not plus, my bad. This is because we are still on vectors. X sub 1, x sub 2, y sub 1, y sub 2. Before we could use the transformation, let's add the vectors. So you have your x sub 1 plus y sub 1, and you have x sub 2 plus y sub 2. This will be your entire first component. This is your second component. So if we're going to use now the transformation, you will have here the first component, x sub 1 plus y sub 1 plus a certain 3, and then we are going to have the same second component as declared here. Of course, what can we do here, let me use spaces, is to isolate or to regroup the x and y components so that we could come up with the transformation of the x and y later. But of course, the 3 here should go with a certain component. But since we only have 1 or 3, we don't have 6, right? So we can just simply rewrite this as x sub 1 plus 3 and then plus y sub 1, where this will meet here, but your y sub 1 doesn't have any 3. So probably that's already a hint to you. Of course, x sub 2 plus y sub 2 is still as it is. Now, if we're going to take this component and this, and then pair these two later on another, we could have here x sub 1 plus 3, then x sub 2, okay, plus your y sub 1, and then y sub 2. This is actually the transformation, okay, of our x vector. Okay, x sub 1 plus 3, and you have x sub 2. So this can be rewritten as a transformation of your vector x. However, we cannot say that the second is also a transformation of our y vector, because the transformation of y, by this definition, should have a plus 3 here. This would mean we can just simply write this like this. Transformation of x plus a certain vector y sub 1, y sub 2, which cannot be expressed, because this is again cannot be expressed as a transformation of your y vector. For this item alone, we can say that the first condition is not satisfied. Okay, so, or let me say here, not satisfied. With this, we can just automatically say that the given transformation is not a linear transformation. No need to proceed to the second condition, since the first condition has already been proven that it will not satisfy the given condition for linear transformation. So again, no need for this. No need for this. Since we have established already that this is not satisfied, and hence this is not a linear transformation. So that's how you check or to verify whether a given transformation is a linear transformation or not. Thank you very much for watching.